Quantum physicists hold individual atoms in place for first time. In a groundbreaking experiment, quantum physicists at the University of Otago in New Zealand have figured out a way to hold individual atoms in place, offering up an unprecedented glimpse at the way they interact. According to the team, the work could lead to new technology that works on the smallest atomic scale possible, potentially stuffing even more computing power into tiny microchips than is already possible today. New isotope analysis just changed the very timeline of how Earth was born. In the very early days of the solar system, baby Earth took a much shorter time to form than we previously thought. According to a new analysis of the iron isotopes found in meteorites, most of Earth took just 5 million years to come together, several times shorter than current models suggest. This revision is a significant contribution to our current understanding of planetary formation, suggesting that the mechanisms may be more varied than we think, even between planets of the same type, located in the same neighborhood, rocky planets, such as Mars and Earth. MIT developed a simulation to determine the best way to deflect an asteroid. Scientists for decades have theorized how to avoid an impact, and now, researchers have gone so far as to lay out a framework to help determine what method of intervention would be best to mitigate a threat. Their decision method accounts for multiple factors including an asteroid's mass and momentum, the amount of time scientists would have before an impending collision and its proximity to a gravitational keyhole, among others. Hack and his team developed a simulation to help determine the best type of defense based on an asteroid's various properties. The simulation was tested with Apophis and Bennu, asteroids in which researchers already know the locations of their gravitational keyholes, with a variety of variables. Time seemed to be the major differentiator. For example, with Apophis, if they have at least 5 years before it will pass through a keyhole, there would be time to send 2 scouts out, one to measure the asteroid's dimensions and another to nudge it slightly off track as a test before sending a main impactor to deflect it at a later date. If keyhole passage is set to occur between 2 and 5 years out, there may only be time for a single scout. Should the asteroid pass through a keyhole within a year or less, it could be too late to intervene. Using the simulation tool, Hack and team may be able to set up alternative deflection methods in the future, such as launching projectiles from the Moon or using defunct satellites as kinetic impactors. Scientists solve mystery of space bacteria on the ISS. When you're living in a remote, isolated environment, things like bacteria and viruses can wreak havoc in a very short period of time. The International Space Station definitely qualifies as being remote and isolated, so when a pair of bacteria species were detected in a water dispenser on board the space station, scientists wanted to know how big of a risk they may pose. The bacteria that were detected in the water system are similar to those known to cause infections, but only in rare cases. The fear, of course, was that the bacteria may have changed or mutated into strains that were more difficult to deal with, thereby posing a serious threat to the crew. As a new paper published in PLOS One explains, that's not the case. Upon discovering the bacteria years ago, researchers collected samples of them in the hopes of learning more about them. Learning how the bacteria differ from those on Earth can go a long way to determining just how dangerous they are, and since ISS residents are incredibly vulnerable in space, this was incredibly important. The good news is that the bacteria species that had mysteriously popped up in the water dispenser aren't actually any more dangerous than similar bacteria living on Earth. Obviously, the International Space Station crew would prefer that there be no bacteria in their water system, but it is a significant comfort to know that there are no mutated superbacteria chilling out in the orbiting laboratory. Recent studies have revealed the space station to be packed with all manner of bacteria. Scientists have debated whether or not this is a bad thing, though because humans carry many bacteria on their bodies naturally, the spread of such microorganisms to the ISS is indeed inevitable. species of bacteria that fights climate change discovered by Cornell scientists. Cornell researchers have found a new species of soil bacteria, which they named in memory of the Cornell professor who first discovered it, that is particularly adept at breaking down organic matter, including the cancer-causing chemicals that are released when coal, gas, oil and refuse are burned. Thanks for watching the Science News. For more details please visit widelyexplore.com.